So from this here, a random variable w has a discrete uniform distribution where the probability of w equals w is given by 1 over 5 for w 1, 2, 3, 4, and 5. Find the probability that w is equal to less than 3.5 and greater than or equal to 2 for the first part there. All right, so question for A, the probability that w is greater than 2 or equal to and less than 3.5. Okay, if I have to draw up the probability distribution table for this, so we got w is 1, 2, 3, 4, and 5, and the probability of w equal to w is given by 1/5. And rightfully so, because if they add up, if we add up the probabilities, it adds up to 1. So the probability that w is between 2 and 3.5 would lie in that region there, which means that it would be 2 of those, basically. So it'll just be 1 over 5 plus 1 over 5, which is 2 over 5. As simple as that, right? Okay, let's leave that probability distribution table up there in case we need it for the next part. Okay, so this is my table of probabilities just to refer to. Okay, let's go to the next question now. The next question says, the discrete random variable x, right, is equal to 5 minus 2w. Okay, let's write that down. X equals 5 minus 2w. We want to find out what is the expected value of x. So therefore, we want to find out what is the expected value of 5 minus the expected value of 2w. The expected value of a value would be 0. And this would be 2 times the expected value of w. Not some, expected value. So this is going to be equal to that over there. Okay. Now, the expected value of w is the mean of w, and we know what the mean is. The mean is given by, or the expected value of w is given by finding the probability of w, right, times each of the outcomes. In other words, we could calculate straight from here by just multiplying each of these. Let's calculate that quickly from there. The expected value of w is going to be given by 1 times 1 over 5 plus 2 times 1 over 5 plus 3 times 1 over 5, etc. You just take out 1 over 5, 1 plus 2 plus 3 plus 4 plus 5. That's going to be 9, 12, 14, 15 divided by 5, which is 3. Okay. So if I add this up, 1 plus 2, it'll be 3 plus 3 is 6, 10, 15. 15 times 1 over 5. 15 divided by 5, which is 3. And we also know that actually the expected value of 5 is not 0. Expected value of 5 is not 0, right? If we distribute the expected value of 5 in the mean of 5 across, if you have everything, I mean, it's the same value across. So it's going to be 5. So now that makes more sense. What I'm going to do now is substitute this 3 in there. And that's going to give me 5 minus 2 times 3. And so that's equal to 5 minus 6, which is negative 1. All right, manipulating expected values from there. Just make a note, the expected value of 5 is 5 as we distribute the e into both sides. Okay. All right. Let's go to part C. For part C, what we have here is to find the probability that x is less than w. Firstly, we know what is w. W is all of these values. We want to find the probability that x is less than w. So after you've coded it, what's the probability that it's less than itself? Okay, or the other way around, greater than itself. So this is where, if I have to rewrite this, this is the probability of x less than. Now we know what x is. X is 5 minus 2w is less than w. Again, just replacing it. Moving this across, the probability that 5 is less than 3w, and then turning it around and dividing it by 3, the probability, I'll just put it the other way in a bit, divided by 3, the probability that w is greater than 5 over 3. 5 divided by 3 is 1.67. All right. So the probability that it's greater than 1.67, firstly, would be all of those values there. That's 4 out of 5 values. It's done. Yep. Because that's the probability that w is greater than or equal to 2, or the probability that w is greater than 1. Okay, let's go to part D now. Find the probability distribution of y if y is 1 over w. Okay, so now we got to create another table of values. And this table of values would be where we've got y. So y is going to be equal to 1 over w. So if w is equal to 1, y is 1 over 1. W is equal to 2, it's a half. W is equal to 3, it's a third. W is equal to 4, it's a quarter. If W is equal to 5, it's a fifth. All right? So y is equal to 1 over w. The probability of w, however, is given as 1/5. So the probability of y, should it be the same? In the probability distribution of y is just changing that into, it's changing w, which is these readings, into 1 over each of them. So if this is now going to be given as 1 over w, should that be exactly the same? That's the question there. So if we know that the probability of w is equal to 1 over 5, and w is equal to 1 over y, right? If we rearrange this, therefore the probability of 1 over y will also equal to 1 over 5. All right? And at the same time, why would the probability still remain 1 over 5 though? Even though we don't use such a complicated calculation there. We have 5 outcomes, and we're saying that it's a discrete uniform distribution, so they have equal outcomes. So we will stick with that. Right. So we got a new distribution table now over there. The next question says find the variance of y showing you're working. So variance of y, this is part 1, is going to be given by the expected value of y squared minus the expected value of y all squared. Because we're dealing with expected values, we need to memorize these formulae. So now what we have to get is each of these. The expected value of y we can calculate by simply adding all of these up and then calculating it. So question D, part 2, the expected value of y will be given by 1/5 and then adding up 1 plus half plus a third plus a quarter plus a fifth. And that comes to 0.4566. So the expected value of y squared is exactly the same thing, except we just square each of these. Okay, now that I've got that, I can calculate this part here, and this will be 0.2927. So now we take that value and we subtract that value squared. Okay. So we're going to end up with 0.2927 minus 0.4566 all squared. And that comes to 0.0842. 0.0842, which will be my final calculation. All right, let's move on to part E now. Part E, find the variance of 2 minus 3y. That's the variance of 2 minus the variance of 3y. The variance of 2 is 0, and 3, when we take it out, becomes 9, multiplied by the variance of y. And we've just calculated the variance of y, which is going to be 9, which is 0.80842 multiplied by -9. So the variance comes to, by the way, this is going to become -3 all squared when we take it out. The -3 will become squared, actually, which will be +9. And then 9 multiplied by 0.0842 becomes my variance, which is 0.758. All right, so we have to know this and how to apply distributing variance into a coded form like 3y like that. That ends up as 0. That ends up as 9 variance y. Okay, and that's where we just plug that in over there and we get the answer 0.758 for that.